Okay, so we're going to look at some more equations. So this time we're looking at a little step on from the last time. This time with our equations, we're going to have letters on both sides. So in the last ones, we just had letters maybe on one side. So it was like x plus 7 equals 4, or 3x plus 2 equals 15. This time we're going to have equations like the ones you see here. So like 2x plus 4 equals x plus 5. And with these, we have to kind of pivot a slight little bit. We're kind of adding on an extra layer to the steps that we have. So our goal is still to have x is equal to something. Okay, or y is equal to something, or k is equal to something. Okay, and we'll change up the letter maybe at some stage. But the goal is still the same as we've had. So in order to achieve that, what we're going to aim for is to have letters on the left, numbers on the right. We're going to keep that as our goal. Because from the previous section, our goal was to have x on the left on its own. So we're going to keep that the same. We're going to always try and get all the x's to one side, all the numbers to the other side. What we need to add on to our kind of list of steps here is that the first thing we're going to move is going to be the x's. Okay, so the first thing we're going to move is going to be the x's. So let's just make note of that. So the first thing to move we'll move is any x that's on the wrong side. The reason we're going to start with that is because from the previous section, we're used to ones where it's maybe x plus 7 equals something like that. So if we can get to that point, then we know how to do those ones. So we're going to try and get to that point as quickly as possible. So let's just apply this to the example. Besides that, our steps are the same. We're still using our inverse operations. We're still doing the opposite. We're doing all of this the same way. So looking at this first one here, the x that's on the wrong side is this x here. Okay, I would like to get rid of that. So at the minute, that's plus x. That's 1x on its own, so it's plus 1x. The opposite of that would be minus x. So let's go with that. So 2x plus 4, and I'm going to minus x here. Do the same thing on the other side, is equal to x plus 5 minus x. Okay, so let's just kind of go through this now. So on the left-hand side, I have 2x minus x. Okay, so here I have 2x and I have minus x. So that altogether gives me 1x. I still have the plus 4. And then on this side, I have just 5, because x, take away x, just gives me 0. So I'm just left with the 5. Now we're back to the ones we're used to doing. So I want to get rid of that 4. So the opposite of my plus 4 would be a minus 4. And same thing here with the 5. I'll get a minus 4 here. And I get that x is equal to 1. Okay, and that's me following it through. Perfect. Next part. Okay, let's do another example. So we're doing the same steps here, same as we did in the last video. We're just going to do example after example and follow it through that way. So let's do the next one. We want to, again, get rid of the x's that are on the wrong side. So that's the 7x here. So my first step is going to be to get rid of that 7x. So let me just set it up. So on my right-hand side, I need to take away 7x. And to do that, I need to do the same on the left-hand side. What I do to one side, I have to do to the other. So it's the same as we had from before. That on the left-hand side is going to leave me with x minus 4 is equal to 3. Then I need to add on 4. So now that's leaving with, on the left-hand side, I just have x. On the right-hand side, I have 7. Okay, so again, following through our steps the same way as we have been doing. So we're just keeping them consistent, keeping them the same the whole way along. Do the next one. So 2x plus 4 is equal to x plus 6. So again, same idea, following the same steps. We want to get rid of that x first. Okay, so to get rid of that x, at the minute it's just plus 1x. So what we need to do to both sides is take away x. On the left-hand side, that's going to leave me with x plus 4 equal to 6. Then what I need to do to each side is I want to get rid of that 4, so I'll take away 4 from both sides. Again, as we've kind of said, it can seem like we're doing a lot of extra work, but we're just making it really, really clear what we're doing at each step. And again, it's all in making us kind of know what's happening at every point in the equation, because it helps us with kind of bigger ones and with kind of more complicated ones and that idea. So even looking at this next one here, so 3x minus 2 equals x plus 3. So obviously, again, the first thing I want to get rid of is that x. So let's take away x from both sides. That's going to leave me with 2x minus 2 is equal to 3. So again, the next thing I want to do is get rid of that 2. So we should remember that the opposite of minus 2 would be plus 2. Solving these then from then on the same as the previous ones. And then here I want to divide by 2. And we get that x is equal to 5 over 2, which is the same as 2.5. And that's okay. We're allowed to have a fraction, we're allowed to have a decimal. Looking then at these next few examples, there's something ever so slightly different with some of these. So looking at the first one, we can see that on the left hand side we have maybe a minus x. We're going to approach it the same way. So x minus 15 equals 9 minus 2x. So again, I would like to move this 2x. And at the minute it's minus 2x, so the opposite would be to add 2x. And I'll do that to both sides. What that means I have on the left hand side now is 3x minus 15 is equal to 9. Then I want to get rid of that 15. So again, as we've said, it's the same thing then from there on out, following the same steps. 9 plus 15. So 3x is equal to 24. And then we need to divide both sides by 3 to get that x is equal to 8 as our answer for that. So again, from kind of this point on, it's the same as the ones in the previous video. So it's making sure that you're comfortable with those ones obviously first. Looking at the next one here, we're going to do the same idea. Now it is going to lead us to something that's maybe a little bit more messier looking, but it's still okay. So again, we want to get rid of that 5x here because it's on the wrong side. So we'll take away 5x and we'll do the same over here. Now we're led to something a little bit more confusing here because we have minus 5x or negative 5x and we have plus 3x, and altogether that gives me an answer of minus 2x plus 2, and that's equal to 6. And we're going to follow it through the same way. Even though we now have minus 2x, that's not going to change what we do at any point here. So I'm following my steps the same way. I want to get rid of that 2. So now I have minus 2x is equal to 4. And the same thing, I want to get rid of that minus 2, so I'll divide by minus 2. And what that's going to give me is x is equal to minus 2, because 4 divided by minus 2 will give me a minus 2 as well, because a plus number divided by a negative number gives me a negative number. So we can see there was a slight difference because we had that negative number ending up in our x part, but that's okay. We can still follow the same steps. We can still work it through the same way. So that's one to make sure that you're kind of happy with, I suppose. Same idea is going to apply here. So we want to get rid of that 5x first. Okay, so let me give myself some space. 5x minus 8. So I want to get rid of this 5x, so I'm going to be taking away 5x from both sides. Okay, so we're getting rid of this one here. That leaves with minus x minus 3 equals minus 8. Okay, again, I want to get rid of that 3, so let's add on 3 to both sides. So we add on 3 here, and we do the same thing here. So I get minus x is equal to minus 5. And again, I would get rid of that minus 1 in front of it. So I'm going to divide this by minus 1 and do the same thing over here. Because remember, x is the same as 1x, which means that minus x is the same as minus 1x. And if it was minus 2, we'd divide by minus 2. If it was 4, we'd divide by 4. If it's minus x, we'll divide by minus 1. And that will give me an answer of x being equal to 5. Okay, so slightly different there. There's some kind of extra thinking we have to put in. And it's coming back to our integer rules. We just need to make sure we're comfortable with those. What I'm going to do next is what we'll call an alternative method. So it's another way of doing those last ones. Okay, and this one is maybe, it's a slight variation on the same steps. It's the same idea. We're just going to end up with something slightly different because we'll end up with x's on the other side instead. And it's only really used, I suppose, in kind of specific cases really that we would need to use it for. So say those last two examples that we just had. So again, it's more if you're comfortable with these questions that you feel that maybe this would just make more sense to you. So what we're going to start off by doing is we're going to look at the equation and we're going to see which side has more x's. And looking at it, we can see that the side with the most x's would be this side here, because it has 5 x's. This side has 3 x's. So what we're going to try and do is we're going to get all my x's on this side, and we're going to put all my numbers on this side. So kind of slightly opposite of what we had from before, but that's okay. So that means I need to get rid of this 3x on this side. So to get rid of that, I would take away 3x, and on the other side, I'll do the same thing. I'll take away 3x. What we get now is all I'm left with is 2 here, and I'm left with 2x plus 6 here. Again, same again, I want to get rid of that 6 on this side. Okay, so I want to get rid of the 6 on this side. So 2, I'll have to take away 6 here. And again, same here. And that leaves me with minus 4 is equal to 2x. Then I'm looking to divide by 2, both sides, and I get that minus 2 is equal to x, which is of course the same as rewriting that x is equal to minus 2, okay? And same as we got the last time, okay? So we can apply it either way, and we still get the same answer. This method, I suppose the original method, is maybe closer to our normal steps, and despite it having that minus number in front of the x, it's still kind of following the same idea. This new one, I suppose, it is, again, it's still following the same steps. We just have those x's on the other side than we're used to, so that might throw some people off. So if that's throwing you off, just stick to the one that we know, stick to the method that we know. It's not that this is a better method, it's not that we're going to eventually get to this method. This is just a different method. It's just an alternative method. We should be comfortable using our integer rules, because that's going to be important as well. And these sums of dividing by minus 2 and those sort of things, those are things you can use your calculator for if you're a bit unsure, if you want to check that you're following the rules correctly. Let's just look at this second method for this second question. So same idea, this right hand side has the most x's, so we're going to move all my x's to that side. So I will take away 4x from this side, and we'll do the same thing on the other side. 5x minus 8 minus 4x. It gives me minus 3 is equal to x minus 8. Then I'm going to get rid of that minus 8 from the right hand side. Okay, so this can kind of feel like we're working a bit backwards here. And it gives me that 5 is equal to x, or x is equal to 5. So again, same answer we got, following the same idea, but we're just working that little bit kind of the opposite way, and it can be a little bit confusing. So as I've said, if this is just not working for you, if you're looking at it and thinking, I do not know what's going on, then stick to this way. Okay, as I said, it's not a better way, it's just a different way. So stick to this way if you're happier with it, because this is more consistent and more maybe in line with the steps that we're doing. And with this way, you will still get the exact same answer. You'll follow it through. The only thing you have to be maybe worried about is, and not even worried, but just particular about, is the minus numbers, the negative numbers, whether we're dividing or multiplying by them, and how that maybe changes our answer. But that's something that's worth getting to grips with. So I wouldn't just do this other method to avoid that, because you need to be comfortable with your negative numbers and your rules that go with those. But overall, the main idea or the main takeaway from this one is this idea of we looking at where the x's are and trying to get all the x's onto one side. Okay, whether you're following either method, that's still what it boils down to. We're trying to get all the x's onto one side and then eventually get all the numbers onto the other side. But our first move is to move the x's. Then we can sort out the rest of it after that, but we move the x's first, and then we follow from there. So just make sure you're going back over these ones and back over the previous ones if you need to. If you're not sure of maybe the later stages in this one, then that might be a sign that you need to look back on the previous one again.